Welcome students, chapter 5, end of chapter exercise solutions. First question, in a circle, a chord is 5 centimeter away from the center. If the radius of the circle is 13 centimeter, what is the length of the chord? So let's take a chord AB here. AB is a chord. We need to find length of AB. AB is equal to what length? Given information, 5 centimeter away from the center. If this is O, if we are taking this, OC is 5 centimeter away from the center. We know very well when we are calculating distance, that is nothing but the perpendicular distance. This is definitely a perpendicular distance. The radius of the circle is 13 centimeter. Radius here OB is equal to 13 centimeter. We have to find AB. So when OC is perpendicular to AB, C is the midpoint. So CB is equal to AC is equal to half of AB. Half of AB. So CB is equal to twice CB. AB is nothing but twice CB. Length of the chord, if we are taking a triangle OCB, in the triangle, length of the chord, using the triangle, if we are finding length of CB, then twice CB is nothing but AB, because CB and AC both are equal lengths, that is half of AB. So in triangle OCB, we know that angle C is 90 degree, opposite to that hypotenuse. So CB length is equal to hypotenuse squared minus another side squared, OC squared. OC squared is 5 squared. So CB is equal to square root of 169 minus 25. CB is square root of 144. 169 minus 25, 144. CB is equal to 12 centimeter. So length of CB is 12 centimeter. While you are calculating length of the chord, AB is equal to 2 times CB, 2 times 12. So AB is equal to 24 centimeter. Length of the chord is 24 centimeters. So the conclusion, length of chord AB is equal to 24 centimeter. Next question, an arc of a circle subtends an angle 70 degree at the center. Let's take the arc, this one, AB is the arc. That arc subtending 70 degree at the center of the circle. This is 70 degree. Then what is the measure of the angle subtended by the arc at the point on the circle? Let's take a point C on the circle. Let's take a point C on the circle. So the same arc AB, what angle it can have at a point C we need to find. So you know very well the relation between the center angle and other side angle. Other side, the arc's other side angle is nothing but that is ACB. Angle ACB is half of angle AOC. Center angle, half of center angle is nothing but other side segment angle. So half of 70 degree angle ACB is equal to 35 degree. So when center angle is 70, the other side angle of the arc is 35 degree. Next question, the diameter of the circle is 26 centimeter. We can take, this is the diameter of the circle, AB is the diameter, then this is O. So here given diameter of the circle AB, D is equal to 26 centimeter. Then radius, that is OA is equal to OB, both are radius, that is half of 26, 13 centimeter. A chord of length 24 centimeter is drawn in this circle. Let's take this point C and this point D. CD is a chord. Length of CD is given 24 centimeter. Find the distance from the center of the circle to the chord. So we need to find this distance O to Let's take a point, this point O to Q. We need to find O to Q. Distance, definitely distance means the distance between two lines. AB and CD are the chords, they are parallel. Distance between that is nothing but perpendicular distance. We need to find OQ. So in triangle CD, length of CD is 24, means Q is the midpoint. Why? Because OQ is perpendicular to CD. Distance we are finding means that is definitely the perpendicular distance. So when a line is perpendicular from the center to a chord, we'll divide the chord into two equal parts. So Q is the midpoint. CQ is equal to QD is equal to half of CD. So the length of QD is equal to half of CD. CD length is 24 centimeter. So QD 12 centimeter. In triangle OQD, right angle triangle, so we have to find the distance from the center of the circle, because we know the radius, we know one part of the chord, length of one part of the chord. We have to find distance from the center. QD is equal to square root of OD squared minus QD squared. So OQ is equal to OD squared 13 squared and QD squared 12 squared. So OQ is equal to 13 squared 169 minus 12 squared 144. OQ is equal to 25. So OQ is equal to 5 centimeter. The chord CD is 5 centimeter from the center of the circle when radius is 13 centimeter. Next question. A circle has a radius 15 centimeter. Let's take the point O, chord AB. So OB is given 15 centimeter. That is radius of the circle given here is 15 centimeter. A chord is drawn. AB is a chord. AB is a chord. The distance from the center of the circle to the chord is 9 centimeter. Let's take the point C. So this perpendicular distance is 9 centimeter. OC is equal to 9 centimeter. What is the length of the chord? As you know very well, length of the chord AB is equal to twice CB. So finding CB, we are going to take a triangle OCB. In triangle OCB, CB is equal to square root of OB squared minus OC squared. So CB is equal to 15 squared minus 9 squared. So CB is equal to 15 squared 225, 9 squared 81. CB is equal to 144. So length of CB is equal to 12 centimeter. AB is twice CB. So AB is equal to 2 times 12 centimeter. AB is equal to 24 centimeter. Length of the chord is 24 centimeter here. Next question, fifth question. Prove that the perpendicular bisector of a chord passing through the center of the circle. Let's take the center O and OC. For the chord AB, take OC is the bisector. So here given a circle with center O. We are taking a circle with center O. AB is a chord and OC is the bisector of OC is the bisector of AB. So we need to prove if angle OCA is equal to angle OCB is 90 means definitely the perpendicular line should pass through the center of the circle. Then we can conclude that O is the center of the circle. OC is perpendicular bisector means if that should pass through the center. For the proof, we are going to take the triangle OCA and triangle OCB. In the triangle, OC is equal to OC, both are common. This is the common side of both the triangles, and OA is equal to OB, radii. And AC is equal to CB, that is the given condition. Bisector, OC is the bisector. So this is the given condition. So by triple S criteria, triangle OCA is similar to triangle OCB by triple S criteria. So by the CPCT, what can we conclude here? Angle OCA is equal to angle OCB by CPCT corresponding part of concurrent triangle. And you know that AB is a straight line. So in card AB is a straight line. So angle at C is 180 degree. So angle ACO plus angle BCO is equal to 180 degrees since they are the linearly pair angle. Linearly pair angle. Linearly pair angle means two adjacent angles sum is 180, then they are linearly pair angles. Because AB is a straight line, so angle at C is 180 degree. It is divided by OC. So angle AOC plus angle BOC is 180 degree. We know that angle AOC and BOC both are equal angle. When we are replacing here angle AOC, BOC as AOC, we will be getting angle AOC is 180. So angle AOC is equal to 90 degree. That is implies angle BOC also, BCO also 90 degree. So both are 90 degree means OC is perpendicular to AB. Therefore, O is the center of the circle. O is the center of the circle. Next question, 6th. The diameter of the circle AB the diameter of the circle ABC is on the circumference. What is the measure of ACB? So here AB is the diameter. AB is the diameter. O is the center of the circle. We know very well angle at O for a diameter is 180 degree. This is 180 degree. Now we are taking a point C on the circle. We have to find this angle. What is this angle? We know very well angle ACB, that is other segment angle, other side angle, is half of the center angle made by the arc. So angle ACB is equal to half of 180 degree. So angle ACB is equal to 90 degree. If a point you are taking C on a circle, if one side of diameter, that angle, the diameter can make an angle with C is nothing but half of the center angle. Center angle is 180, so that angle is 90 degree. Next question, 7th questions. C as ABCD is a cyclic quadrilateral. So you can see a quadrilateral inscribed in a circle, all the four vertices on the circle, then that is called cyclic quadrilateral. Say this ABCD. If the measure of angle A is 75 degree, measure of angle A is 75 degree. What is the measure of angle C? So this one we need to find what is the measure of angle C. If measure of angle B is, this is 110 degree, then what is the measure of angle D? So we know very well, in a cyclic quadrilateral, opposite angles are adjacent to each other. Angle A plus C, angle A and C are opposite angles. So angle A plus C is equal to 1, supplement to each other, not adjacent, sorry, supplement to each other. Opposite angles are supplement to each other. So angle A plus C is equal to 180 degree. Angle A here given is 75 degree. Angle C is C angle. So angle C is equal to 180 minus 75 degree. So angle C is equal to 105 degree. So C angle 105 degree. In same way, next two opposite angles are angle B and angle D. Both are supplement to each other. Angle B plus angle D is equal to 180 degree. Angle B given 110. Angle D is equal to 180 degree. So angle D is equal to 180 minus 110. So angle D is equal to 70 degree. Next question, a quadrilateral PQRS in a circle, P angle is given, R angle is given, find the value of X and measure the angle P and angle R. So let's take the vertices PQRS. Here angle P is given 2x plus 10 degree and angle R is given 3x minus 20 degree. As we know very well, the quadrilateral inscribed in a circle, that is the cyclic quadrilateral. So opposite angles of a cyclic quadrilateral is supplement to each other. So replace angle P as 2x plus 10 degree and replace angle R as 3x minus 20, that is equal to 180 degree. So when we are adding x and x, we will be getting 5x, and plus 10 minus 20 will be minus 10 is equal to 180 degree. So 5x transpose minus 10 to next side, 180 plus 10. So 5x is equal to 190 degree. So x is equal to 190 by 5. So x is equal to 3 times 15, then 4, 38. So x is 38 degree. If x is 38 degree, what is angle P? Angle P is 2x plus 10 degree. So angle P is equal to 2 into 38 degree plus 10 degree. Angle P is equal to 76 plus 10 degree. Angle P is equal to 86 degree. Angle Q is equal to 3x minus 20 degree. Angle Q is equal to 3 into 38 degree minus 20 degree. So angle Q is equal to 104 minus 20 degree. So angle Q is equal to 494 degree. Angle P is 86, angle Q is 94 degree. Next, the distance of a chord of length 16 centimeter from the center. So take a chord, if this is A and B, the chord AB, then the distance of a chord of length 16. So length of AB here given 16 centimeter. From the center of the circle is 6 centimeter. This is the center, then this is 6 centimeter. If you are taking a point C, OC is equal to 6 centimeter. Find the radius of the circle. So AB is equal to 16 centimeter means CB, length of CB is half of AB is equal to half of 16 is equal to 8 centimeter. Length of CB 8 centimeter. In triangle OCB, radius is OB. OB is equal to square root of OC squared plus CB squared. When you are finding radius, that is the hypotenuse, so we need to add square of another two sides. OC squared 6 squared, CB squared 8 squared. So OB is equal to 36 plus 64. OB is equal to 36 plus 64, 100. So OB square root of 100 is 10. Radius of the circle is 10 centimeter. Next, cyclic quadrilateral has a sides 5, 5, 12 and 12 units. 4 sides given. If suppose ABCD is a cyclic quadrilateral, AB is equal to 5 units, BC is equal to 5 units, and CD is equal to 12 units, and DA is equal to 12 units given. So we will take A is 5 units, B is 5 units, C is 12 units, D is 12 units. We will consider like this. So if you want to find area of a cyclic quadrilateral, the formula is square root of, like Heron's formula, semi-perimeter minus A, semi-perimeter minus B, semi-perimeter minus C, semi-perimeter minus D. This is the formula to find the area of the cyclic quadrilateral. While we are finding semi-perimeter, S is equal to 5 plus 5 plus 12 plus 12 divided by 2. That is equal to 34 divided by 2 is 17. Semi-perimeter is 17. So square root of 17 minus semi-perimeter, 17 minus 5, A is 5, 17 minus B is 5, 17 minus C is 12, and 17 minus D also 12. Then 17 minus 5 is 12, 12 into 5 into 5 square units. So when two 12s are there, out of the square root, we can take 1 12, and for the 2 5, 1 5. So 12 into 5 square units. So 12 5s are 60 square units. So area is nothing but 60 square units. Next, 11th question. Consider a cyclic quadrilateral without drawing its circumference. How can we find out whether the center of the circle lies inside the quadrilateral or outside the quadrilateral? Outside. What is the best way to find out? Let's take this quadrilateral ABCD. Here center is inside. Suppose if we are taking PQRS is a cyclic quadrilateral, here the center is outside of the quadrilateral. So without drawing circumference, how to find means, if all the angles, all the 4 angles in a quadrilateral are acute angles, which is A, B, C, D, or here acute angles, so that O lies inside the quadrilateral. O lies inside the quadrilateral. Acute angle means less than 90 degree. You know very well, acute angle less than 90 degree. All the 4 angles are less than 90 degree. then the center lies inside the quadrilateral. Here you can see angle S and angle R are not, these two angles are obtuse angles. They are not less than 90 degree. Angle S is greater than 90 degree. Angle R also greater than 90 degree. So without drawing circumference, if any one angle or any two angle of a quadrilateral are obtuse angles. So any angle of the quadrilateral is obtuse, then the center lies outside the circle, outside the quadrilateral, lies outside the quadrilateral. So very simple, if all the angles are less than 90 degrees, center lies inside the quadrilateral. Any one or two angle greater than 90 degree, then that center lies outside the quadrilateral. 12th sum, when two chords are given, two chords are intersect each other is divided into two line segments. Let's take a chord AB and a chord CD. They are intersecting at a point E. So we can see two segments. AB is divided by AE and EB. These are the two segments of AB. And CD is divided by CE and ED. These are the two segments. So that intersecting chord are equal in length. If the intersecting chord are equal in length, then the line segments of the chord are equal to the corresponding line segments of the chord. So here given the chord length are equal, which is AB is equal to CD. Chord length are given. To prove corresponding segments are equal, that is, in chord AB, BE is the small segment. For chord CD, CE is the small segment. So minor segments, these two are minor segment which are equal. So chord AB this segment and chord CD this segment, they are equal. And major segment, chord AB major segment is AE, that is equal to chord CD major segment is DE. So we need to prove this corresponding segment. This segment is equal to this segment. For that we are going to take a point center. O is the center. So when O is the center, take P and Q are midpoints. P is the midpoint of AB and Q is the midpoint of CD. So for the proof, we are going to take P is the midpoint of QD. So when we are dropping center to midpoint, that line is perpendicular line. That is OP is perpendicular to AB and OQ is perpendicular to CD. OQ is perpendicular to CD, which means two chords are equal in length. So their distance from the center also equal. So if given condition AB is equal to CD, if we are getting OP is the distance from the center to chord AB, means OP is equal to OQ is the distance of a chord from the center. OQ is equal to CD. That distance also equal. When equal chord or equidistance from the center, this is also the point we can get. Then when OP is perpendicular to AB, means P is the midpoint. So AP is equal to PB is equal to half of AB. In this chord CD, Q is the midpoint. So CQ is equal to QD is equal to half of CD. Now, if we are connecting O to E, we are joining O and E, we will get two triangles. So, in triangle OPE and triangle OQE, in these two triangles, we are checking concurrency, means OE is equal to OE, the sides are common. That is the common side for two triangle. And angle OPE is equal to angle OQE. That is the perpendicular angle, 90 degree. This angle is 90 and this angle also 90 degree. Then opposite to 90 only OE. So this is the hypotenuse. This is 90 degree. Then one more side, which is the perpendicular distance. OP is equal to OQ. That is given. When the two chords are equidistant, then the distance from the center to the chord is equal. Therefore, triangle OPE is concurrent to triangle OQE by RHS criteria. So, by the CPCT, we can conclude PE is equal to EQ. The another side, by CPCT, we can conclude that PE is equal to EQ. So, we will take this as first equation. Now, prove the segments we will take. That is, we know that AB is equal to CD. So, half of AB is equal to half of CD. Half of AB, I am going to take PQ. Half of AB is nothing but PB. So, PB is equal to half of CD is CQ. So, PB is equal to CQ. Now, this is second. Now, 2 minus 1, subtract this. That is PB minus PE is equal to CQ minus EQ. What can we get? PB minus PE, because both are equal in length, no? So, we are subtracting equal quantity from equisides. PB is equal to CQ, they are equal, and PE is equal to EQ, that is, they are also equal. When we are subtracting same length sides, we will be PB minus PE is nothing but BE, and CQ minus, look at the diagram, CQ minus EQ is CE. So, we proved minor segments, corresponding minor segments are equal. Now, same way, we know AB is equal to CD, half of AB is equal to half of CD. Now, we can take half of AB is AP. Suppose we are taking, that is the next side, no? AP is equal to here DQ or QD. Now, this is third. If we are adding 3 plus 1, we will be getting AP plus PE is equal to QD plus EQ. Equal quantities are added. So, AP plus PE is nothing but AE, segment AE, and QD plus EQ is DE, the segment DE. Now, corresponding major segments are equal. Now, this is minor segment, corresponding minor segments. This is corresponding major segments. So, corresponding minor segment and major segments are equal. So, hence proved. Next question. Draw a circle in which a chord 6 cm of length stands at a distance 3 cm from the center. So, where here take a chord 6 cm of length. If we are taking a chord 6 cm of length, take a chord AB 6 cm of length and mark C at C centimeter, 3 centimeter. This is 3, this is 3. So total length is 6 centimeter. C is the midpoint, 6 centimeter. Then length stands at the distance 3 centimeter from the center. So now here using your protractor or using your compass is draw a perpendicular line here. Draw a perpendicular line for 3 centimeter. That is also 3 centimeter. Then using compass from here to A or from here to B, if we are measuring and drawing a circle, we will be getting the circle with circumference that with some radius. If we are drawing a circle, we will be getting radius, that is radius O. This is O means OA is equal to radius. Using compass, measure OA and draw a circle. OA and OB are equal. We can draw a circle. If we want to find what is the length of OA, that is 3 squared plus 3 squared. So OA is equal to 3 root 2 centimeter. So the circle radius is 3 root 2 centimeter. Show that a rectangle is the only parallelogram that can be inscribed in a circle. Let A, B, C, D is a parallelogram inside inscribed in a circle. So given A, B, C, D is a parallelogram. So we need to prove that A, B, C, D is a rectangle. We need to prove that this is the rectangle. For the proof, we have to take we know in parallelogram, that is parallelogram is a rectangle means sides no issue. For parallelogram also opposite sides are equal and parallel. Rectangle also opposite sides are equal and parallel. But what is the difference between rectangle and parallelogram means? In rectangle, all the angles are 90 degree, but parallelogram, opposite angles are supplement to each other. Opposite angles are equal, adjacent angles are supplement to each other. So, if A, B, C, D is a parallelogram means opposite angles are A is equal to C and B is equal to D. B is equal to D. At the same time, ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. So, accepting that condition, opposite angles are supplement to each other. Angle A plus C is equal to 180. So, when we are having A is equal to C means twice angle A is equal to 180. So angle A is 90, as well angle C also 90. If you are taking another side, angle B plus angle D is equal to 180 for a cyclic quadrilateral. So twice angle B is equal to 180 means angle B is equal to 90 degree. Now for all the angles are 90 degree. That is angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree. Therefore, ABCD, the parallelogram ABCD inscribed in a circle, that is nothing but the rectangle. Fifteenth question, show that if the rectangle is inscribed in a circle. So, AB, CD, a rectangle inscribed in a circle, then point of intersection of diagonal must lie at the center of the circle. So, given here is ABCD is a rectangle. So, we have to find we have to see the diagonals. Let's join AC. AC is one diagonal. and BC is the BD is the another diagonal. Now by the diagonal property of the rectangle, the diagonals are bisects each other. Rectangles diagonal property nothing but diagonals are equal and bisect each other. So we have to prove here the diagonals must lie at the center of the intersection of the diagonal. So intersection of the diagonal, this is nothing but center of the circle. That is O is the intersection of AC and BD. So we have to prove O is the center of the circle. We have to prove. For the proof, we know that AC, length of the diagonal in a rectangle, equal. AC is equal to AD and O is the bisector. O is bisector of AC and BD. O is the midpoint of AC and BD. Length also equal and OC. So if suppose OC is the bisector, means for AC, OA is equal to OC, and for BD, OB is equal to OD. So AC is equal to BD, which means half of AC is equal to half of BD. So half of AC, if I am taking OA, that is equal to half of BD is OB. So OA is equal to OB. Already I am having OA is equal to OC. So OA is equal to OB is equal to OC is equal to OD. All the four lengths are equal. So A, B, C, D are the points on the circle. You can see A, B, C, D, all the 4 points are the circle. Point A, B, C and D are on the circle and equidistance from the center. That is OA is equal to OB is equal to. So that is the definition of the circle. The points, collection of points equidistance from the center is nothing but the circle. So that distance is the radius. So OA is equal to OB is equal to OC is equal to OD is the radius of the circle. So O is the center of the circle. We can conclude here O is the center of the circle. 15th question, consider all the chords of a circle of a fixed length. What is the shape formed by the midpoints of these chords? In a circle, infinitely many chords are there. Whatever the circle we are taking, infinitely many chords are there. So when we are taking fixed length chords, that is same length chords, infinitely many same length chords. If this is length 3 means again length 3, again length 3, like this infinitely many chords we can take. If we are joining the midpoints of that, again we will be getting a circle with center C. So joining the midpoint of the fixed length chords, we will be getting smaller concentric circles. We will be getting many smaller concentric circles. Seventeenth question. In a circle with center O, a chord AB and AC are congruent. Explain why this statement is true. The center of the circle lies on the angle bisector of BAC. So this is the circle, and let's take the chords AB and AC. If this is chord AB and this is the chord AC. These are the two chords, and here given length of AB is equal to AC. Two concurrent circles mean the concurrent chords means their length are equal. Then taking center O and joining this center with the radius, so we joined with the center, and next one line if you are joining our A and O, then we need to prove that angle BAC. To prove the center of the circle lies on the angle bisector of BAC, that is angle BAC is equal to BAC divided by angle OAB is equal to angle OAC. That is OA is the angle bisector of angle BAC. We need to prove OA is the angle bisector of BAC. So for the proof, we are going to consider two triangle OAB and triangle OAC. In this triangle, OA is equal to OA common side. Then OB is equal to OC, radius of the circle. Then AB is equal to AC given. They are the concurrent paths given condition. So, by the CPCT, OAB is concurrent to triangle OAC by triple S criteria. So, CPCT we can conclude that OAB, angle OAB is equal to angle OAC, which means these two angles, that is this angle is equal to this angle. That means OA is the angle bisector. Angle bisector of angle BAC. So, the center of the circle lies on the angle bisector. Center of the circle O lies on the angle bisector. 18th question. Two parallel chords of length 10 centimeter and 24 centimeter are on the same side of the center of the circle. The distance between the chords 7 centimeter. Find the radius of the circle. Look at the diagram. Here our two chords, parallel chords are AB and CD. So given AB is parallel to PQ. AB is parallel to PQ and length of AB is 10 centimeter and length of PQ is equal to 24 centimeter. This is the information given. So we need to find what is the radius. To find radius of the circle. What is the radius of the circle? For the proof, we are going to take we're going to take OC from the center. We are dropping a perpendicular. OC is perpendicular to AB. So we can get this implies AC is equal to CB is equal to half of AB, that is 5 centimeter. So in the next chord we are dropping perpendicular, say OC PQ, or take this point as R point. So if OR is perpendicular to PQ, then we can get PR is equal to RQ is equal to half of PQ is equal to PQ length is 24. So half of PQ 12 centimeter. So we are getting CP 5 centimeter and QR 12 centimeter. Then we need to find the height. And here it is given distance between the parallels. Here in the diagram, distance between the parallels CR. CR is given 7 centimeter. Distance between the parallels 7 centimeter in the question it is given. So CR, look at here, this is the distance between the parallels. CR is 7 centimeter. And from O to R, we don't know the distance. So we will take, let OR is equal to X centimeter. So what is OC? OC is equal to X plus 7 centimeter. We will be getting OC X plus 7 centimeter. Now, in triangle OBC, now we are going to consider the triangle OBC. That is, look at the triangle. This is OBC. Separately, if we are taking center to B, OBC. Now, CB length is 5. OC length is X plus 7 and OB is radius. So using Pythagoras, this is 90 degree, we know that. So using Pythagoras, R squared is equal to square root of X plus 7 the whole squared plus 5 squared. Same way, if we are taking another triangle, in triangle for PQ, for the chord PQ, if we are taking triangle ORQ, that is, this is the triangle ORQ. This is R, this is Q and O. The length between OR is X centimeter. Here we took X centimeter. Here given is 7 centimeter. Then this length is 12. Then OR R. R squared is equal to square root of X squared plus 12 squared. This is equation 1. This is equation 2. Comparing equation 1 and 2, our left and right sides are 1 and 2. From 1 and 2, left sides are equal, R squared and R squared, so that we are equating the right hand side. X plus 7 the whole squared plus 25, 5 squared 25 is equal to X squared plus 144. Then squaring on both sides. Squaring on both sides, we can cancel square root. Both sides, we will be getting X plus 7 the whole square plus 25 is equal to X squared plus 144. Expanding X plus 7 the whole squared using A squared plus B squared, X squared plus 14X plus 49 plus 25. Then transposing this to next side, X squared minus 144 is equal to 0. Cancelling X squared and X squared. Then adding 49 and 25. Then subtracting that from 144. Solve the equation. While solving the equation, here we are getting 14x plus 49 plus 24, 4, 14 plus 5, 6, 7. 74 minus 144 is equal to 14. So 14x minus 70 is equal to 0. So 14x is equal to 70 plus 70. X is equal to 5. So we are getting x value as 5. If x value is 5, you can consider this to find R. Any equation, either 1 or 2. First equation, we will be getting R squared is equal to square root of 5 plus 7 the whole squared plus 5 squared. 5 plus 7, 12. 12 squared 144 plus 25. So R squared is equal to square root of 169. So R is equal to 13 centimeter. You can check replacing in 2 also. Second equation gives r squared is equal to x squared plus 12 squared, x squared 25, 12 squared 144. Sum of these two 169. So r squared is 169. So r is equal to 13 centimeter. Radius of the circle is 13 centimeter. Next, a regular hexagon is inscribed in a circle of radius r. Find the length of the side of the hexagon and the distance of the side from the center of the circle. If this is the center of the circle, if we are joining this one, say take this triangle, if we are joining this, we will be getting radius. And what about this angle? We know how many triangles can we get? That is A vertex, B vertex, C vertex, D, E, F. So each vertex joined with the center, we will be getting 6 triangles. Angle at O is 360 degree. So O angle divided into 6 parts. So each angle, for example, like if I am taking AOB, angle AOB is 1/6 of 360 degree. So that is nothing but 60 degree. So in triangle AOB, consider the triangle AOB. Here angle AOB is equal to 60 degree and OA is equal to OB is equal to radius of the circle, which means angle OAB is equal to angle OBA. Opposite angle of equal sides are equal. So in the same triangle, if we are applying the angle sum property, that is AOB plus angle OAB plus angle OBA is equal to 180 degree in the triangle. Angle AOB is 60 degree. These two angles are same. So twice angle OAB is equal to 180. Twice angle OAB is equal to 180 minus 60. So twice angle OAB is equal to 120 degree. Angle OAB is equal to 60 degree, which means angle OBA also 60 degree. So all the angles in a triangle AOB 60. Therefore, triangle AOB is a equilateral triangle. So the side length A is equal to R. The side length of the hexagon is the radius. So now in an equilateral triangle, consider the equilateral triangle. If we are finding the distance between the center, this is OAB. OAB is an equilateral triangle. Then this is R, AB is also R. If we are dropping the perpendicular to find this length, the perpendicular will divide this into two equal parts. Say P. OP divide P, the point P divide AB into two equal parts. So this is R by 2. This is also R by 2. So to find in triangle OPB, to find length of OP, that is the length from the center to the chord. OP is equal to square root of OB squared, hypotenuse squared, minus another PB, another side squared. So OP is equal to R squared minus R by 2 the whole squared is R squared by 4. So taking LCM, OP is equal to 4R squared minus R squared by 4 is equal to square root of 3R squared by 4. So the distance between the center to the chord OP is equal to r squared by 4 square number. So we can take outside r root 3. Root 3 we cannot take outside. Root 3 r by 2 units. The distance is r by 3, root 3 r by 2 units. So side of the hexagon, side length of the hexagon is r units and height of the hexagon is root 3 by 2 r units. That is the distance from the center to the chord. Next question, a quadrilateral MNOP is inscribed in a circle. If Mn is diameter, what can you say about the angles? Two angles. What can you say about which angle? Angle MNP and MOP and MNP. These are the two angles. So quadrilateral, if you are taking MNOP, this is the quadrilateral. Here given condition, very important condition, in a quadrilateral one side is a diameter, that is Mn is a diameter of the circle. So we have to find what is the angle Mn. Let's find the angle MOP. Where is MOP? From M to O, if we are joining a line, you will be getting MOP. If we are joining the line, this is the angle MOP. Where is MNP? From P to N, if we are joining the line, that is this angle. This angle is MNP. So this is MOP. This is MOP. This is MNP. What is the connection between these two angles? Say in a quadrilateral, Mn is a chord, On is a chord, OP is a chord and MP is a chord. So consider the chord MP. Let's take the chord MP. So if we are taking the chord MP, here O is a vertex. If you are joining, you will be getting the angle MOP. Then here N is the point, vertex. If you are joining, you will be getting this one, and an arc is there. And an arc is there, which means these two are same segment angles. MOP and MNP are same segment angles. Angles of chord PM. Based on PM, the two are same segment angles. Therefore, always the same segment angles are equal. MOP is equal to MNP. They are the equal angles because they are same segment angles. 21st question. Let ABCD is a cyclic quadrilateral. So A, B, C, D is the cyclic quadrilateral. Explain why the exterior angle at any vertex is equal to interior opposite angle. For example, CDE. So suppose we are extending this till E, we will be getting CDE. Angle CDE is equal to ABC, that opposite angle. So let's see that extend AD to E. So we will be getting at D, we will be getting linearly pair angle. Angle CDE plus angle ADC is equal to 180 degree. Linearly pair. The reason is linearly pair angle. Linear pair angles. So 180 degree. Take this as first equation. But given ABCD is a cyclic quadrilateral. So what about the cyclic quadrilaterals? Opposite angle property. Opposite angles are supplement to each other. So ACD angle plus opposite of ACD is ABC angle. That is 180 degree. This is second equation. This is cyclic quadrilaterals condition. So comparing 1 and 2, right hand side of 1 and 2, 180 degree. So equating left hand side, angle CDE plus angle ADC is equal to angle ACD plus angle ABC. Tappu. First question, ABCD is a cyclic quadrilateral. Explain why exterior angle at any vertex is equal to interior opposite angle. Let's extend AD to E. So we will be having linearly pair angle there. CDE plus angle ADC is equal to 180. The reason is linear pair angles. Say this is equation 1. And given ABCD is a cyclic quadrilateral. So the property of the angle of a cyclic quadrilateral, opposite angles, angle sum is 180 degree supplement. So ADC plus angle ABC is equal to 180 degree. Say this is second equation. Comparing 1 and 2, right hand side both the equations are having 180 degree. So equating the left hand side, ADC is equal to ADC plus angle ABC. So cancel ADC. So angle CDE is equal to angle ABC. That is this angle CDE, this angle is equal to opposite interior angle, this angle. If we are taking another example, suppose we are extending some other side. Say I am extending this side. Say this is F. So another way also we can check. Extend AB to F. So what can we get? We will be getting two linearly pair angles. That is DAF plus DAB is equal to 180 degree linearly pair angle. Linear pair angle. And if we are taking DAB, angle DAB, opposite to DAB is nothing but angle ABC. 180 degree because cyclic quadrilateral. ABC is a cyclic quadrilateral. On comparing these two, 180 equals, so equating the left side, DAF plus DAB is equal to DAB plus angle ABC. So cancel DAB. So angle DAF is equal to angle ABC. So where is DAF? This is DAF. This is the angle DAF. Exterior angle DAF is equal to opposite interior angle ABC. DAF, and this is not ABC, sorry, this is opposite angle ACB. This angle is ACB. Look at the diagram properly. The angle DAB, this angle DAB, and this angle DBC, that is BCD is 180. These are the opposite angles. So DAB and BCD. After cancelling that, we will be getting BCD. So DAF, this is the angle. Opposite interior angle is this. These two are equal. So wherever we are extending, we will be getting correct answer. Exterior angle is equal to opposite interior angle in a cyclic quadrilateral. 22nd question. There is no chord of a circle that is longer than its diameter. How do you justify your answer? If we are taking a diameter of the circle, suppose we are taking a circle, this is the circle with center O and a chord. We are taking a chord. From the center, the distance is D. Then take another circle. Then take another chord. We are connecting this to the center. Say this is O. Here chord AB and chord CD. The length of AB, the perpendicular distance from O to AB is D. The perpendicular distance from O to CD is, say, E. Now, how about the length? AB, length chord AB is greater than CD. But distance from the center D is less than E. So, understand this. That is, the distance from the center and the length of the chord are proportionate to each other. That is, when distance from center is increasing, length of the chord will be decrease. Chord decreases. If the distance from the center decreases, length of the chord will be increased here. Increases. So the chord is further from the center will be the smaller chord. When the chord is closer to the center will be the greater chord. So from the center to the chord, if D is equal to 0, the distance from the center to the chord is 0. There is no distance between the center and the chord. 0 distance, 0 units, means that chord is nothing but the diameter of the circle. So only the diameter is the longest chord. So that we are concluding the dia is the longest card. So when the card is moving further from the center, the length of the card will decrease. When the card is closer to the center, the length of the card will be increased. So the diameter is the longest card. 23rd, let A be a point within the given circle with center O, so that the shortest chord of the circle passes through the point A of A is the one that is perpendicular to OA. Let A be any point within the given circle. So take a point A. This is A point. So that the shortest chord of the circle passes through the point A. So take a chord which passes through the circle A. Passes through the point A. So this is the chord passes through the circle, passes through the point A, and O is the center of the circle. Then it is perpendicular. OA is perpendicular. O, and this is perpendicular. Let AB be the CD be the chord, and this is the perpendicular length. Now let's take one more chord. Let's take another chord passing through O. If we are considering another chord which is passing through O, passing through A. If I am taking the chord PQ, that chord also passing through A, but OA is not perpendicular. From the O to P I am dropping, this is R. R is the perpendicular of PQ. So let CD be the chord through A, and OA is perpendicular to CD. Now, and let PQ also passing through A. Also passing through A, and O, this is O, OR is perpendicular to PQ. If we are taking like this, in triangle ORA, in triangle ORA, OA is the hypotenuse. OA is the hypotenuse because angle ORA is 90 degree, opposite to that is hypotenuse. So OA is greater than OR. That is, distance between CD to the center is greater than distance between PQ from the center. So when the chord is further from the center, that is the smallest chord. Hence here the chord through the point A, and OA is perpendicular to that chord, is the smallest chord, because OA is greater than OR, which implies chord CD is smaller than chord PQ, because OA distance from the chord CD, OR is distance from chord Okay, so OA is greater than OR means CD is less than PQ. So CD is the smallest chord. CD is passing through the center and OA is perpendicular to that chord. That is the smallest chord of the circle through the point A. Next question, 24th question. How would you use the following figure to justify the statement that angle in a semicircle is 90 degree? That is, we need to prove here angle at the semicircle, that is BAC is equal to 90 degree. How to prove BAC 90 degree? From the diagram, BAC is nothing but angle BAO plus angle OAC, that is equal to 90 degree. So we will take a take triangle for the proof. In triangle AOB, OB is equal to OA. Both are radius of the circle, which implies angle OBA is A, means angle A. Given here, angle OBA is equal to A. If the two sides are equal, opposite angles are equal. Therefore, angle BAO also A. The next triangle, in triangle AOC, OA is equal to OC. Two sides are equal, which implies opposite angles also equal. That is, angle OAC is equal to angle OCA. So angle OAC is equal to angle B. From the diagram we can take that angle. Now our required angle, look at the in full triangle, in triangle ABC, use the angle sum property, angle BAC plus angle, I will write there, in triangle we are using angle sum property. In the full triangle ABC, angle sum property BAC plus ABC plus angle ACB is equal to 180 degree. So BAC can be written as BAO plus angle CAO plus angle ABC in the diagram given angle A, angle ACB in the diagram it is given angle B, that is equal to 180 degree, and BAO here we found angle A, so A, and CAO here we found angle B, plus A plus B is equal to 180 degree. So twice of A plus B is equal to 180 degree. A plus B is equal to 90 degree. What is angle A? Angle BAO plus angle B is OAC is equal to 90 degree. So combining BAO and OAC, we are getting BAC, that is equal to 90 degree. So angle at semicircle is 90 degree. 25th question. In a circle, two chords C dash and D dash are drawn perpendicular to the diameter AB. Prove that the segment MM dash joining midpoint of the circle C dash, CD and C dash D dash is perpendicular to AB. Here AB, take this is AB diameter and given CC dash perpendicular to AB. So this is CC dash which is perpendicular to AB and D dash which is perpendicular to AB. So both are perpendicular to AB. and prove that the segment MM dash joining the midpoint of CD. So see here, CD, take this point as M, midpoint of CDM, and midpoint of C dash D dash is M dash. So the lines joining this one, MM dash, midpoint of the chord CD, C dash is perpendicular to AB. So we need to prove MM dash is perpendicular to AB. So how to prove? C dash and D dash are parallel. How it is parallel? AB is a diameter, that is C dash perpendicular to AB and D dash perpendicular to AB. So two lines are perpendicular to same line, which implies that two lines are parallel to each other. C dash is parallel to D dash, because C dash is perpendicular to AB and D dash is perpendicular to AB. C dash and D dash both are perpendicular to AB, means definitely C dash and parallel to D dash. Now joining CD and C dash D dash, we are getting a quadrilateral. So say quadrilateral C dash D dash D. This is the quadrilateral. In that one opposite sides are parallel, which is C dash is parallel to D dash, which implies that quadrilateral is a trapezium. When one pair of opposite sides are parallel in a quadrilateral, then that quadrilateral is a trapezium. Here C dash and D dash are parallel sides, therefore CD and C dash D dash are non-parallel sides. Non-parallel sides. Now the line segment joining the midpoint of this non-parallel sides definitely parallel to the parallel sides. M is midpoint of CD and M dash is midpoint of C dash D dash. So when midpoint, the line segment joining midpoint, the line segment MM dash is parallel to the parallel sides of the trapezium. So MM dash is parallel to C dash and D dash. So MM dash, when this is parallel, definitely that is perpendicular to the diameter. The midpoint of joining non-parallel sides, midpoint, the line segment joining non-parallel side will be parallel to the parallel side. Already the parallel sides are perpendicular to the diameter. Therefore, MM dash is perpendicular to the diameter AB. So, this is also perpendicular. 26th question, how would you use the following figure to justify the statement that sum of opposite cyclic quadrilateral is 180 degree? So we need to prove here sum of opposite angles, that is angle BAD plus angle BCD is equal to 180 degree, or we need to prove that angle ABC plus angle CDA is equal to 180 degree. Sum of opposite angles 180 degree. For the proof, we are going to take separate triangles. Angles are given. So we will write what is given here. The given angles are given angle OAB is equal to P and angle OBC is equal to Q and angle OCD is equal to U and angle ODA is equal to V. This is given. For the proof, we are going to take separate triangles. Consider first triangle. In triangle AOB, in triangle AOB, OA is equal to OB. The sides are equal, that is they are the radius of the triangle, radius of the circle, that is the sides of the triangle, that is isosceles triangle. So opposite angles are equal. So angle OBA is equal to angle P. Then in triangle, next triangle, angle BOC, there also two sides are equal. OB is equal to OC, which implies opposite angles are equal. So OCB is equal to Q. Next, in triangle COD, OC is equal to OD, which implies opposite angles are equal. So ODC is equal to U, angle U. Next triangle, in triangle DOA, OD is equal to OA, which implies angle OAD or DAO is equal to V angle. Now, we can use angle sum property of a quadrilateral. We know that sum of all the angles in a quadrilateral is 360 degree. So when we are adding the angles, angle A plus angle B plus angle C plus angle D is equal to 360 degree. Angle sum property of a quadrilateral. Angle sum property 360 degree. So angle A can be written as angle OAB plus angle OAD. We can split that angle. Then angle B can be written OBA plus angle OBC. Angle C can be written OCB plus angle OCD. Then angle D is angle ODC plus angle ODA. That is equal to 360 degree. Now OAB, look at here, OAB is P. So replace here P. And OAD, where is OAD? OAD is V. So replace V. And OBA, OBA is P. Replace P. Then OBC, OBCQ, replace Q. After OBC, OCB. So we replace for this 1, 2, 3, 4. Now OCB. OCB is Q. Replace. So OCB replaced. OCD. The here U. OCD U. Replace for that for U. Then next to ODC. ODC also U. So ODC we are replacing U. Then ODA. Here B. So for ODA we are replacing V. That is equal to 360 degree. Now 2 P's, 2 V's, 2 U's, 2 Q's. So 2 times P plus Q plus U plus V is equal to 360 degree. So P plus Q plus U plus V is equal to 180 degree. So P plus Q plus U plus V 180 degree. Now we will check opposite angles. Which are the opposite angles? Say angle A plus angle C or opposite angles. Now angle A can be written as, we will check the opposite angles. That is angle A plus angle C. What the answer we are getting? Angle A is angle OAB plus angle OAD. Then angle C is angle OCB plus angle OCD. Now replace here angle OAB. Where is angle OAB here? Angle OAB P. Then angle OAD. Where is angle OAD here? V. Then angle OCB. Where is angle OCB? Here. Q. Then angle OCD. Angle OCD here. U. So, P plus V plus Q plus U is equal to 180 degree. So, angle A plus angle C is equal to 180 degree. Opposite angles are supplement to each other. Let's check the next side. Angle B plus angle B plus angle D. What is angle B plus angle D? Angle B is nothing but angle OBA plus angle OBC. Then angle D is ODC plus angle ODA. Now replace angle OBA. Where is angle OBA? OBA P plus OBC Q and ODC U ODA B. Once again, P plus Q plus U is equal to 180 degrees. So we got angle B plus angle D also 180 degree. So from the figure we can conclude in a cyclic quadrilateral opposite angles or angle sum is supplement to each other. Opposite angles are supplement to each other.